In this video, I'll be working through the question you see on the screen here from the Maths paper 1-1 from the 2024 Cambridge A-Level exam. If you're looking for a different question from this paper, there should be a link to the playlist in the description below. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to in your classroom. But remember, we're not in the classroom, we're on YouTube. Take advantage of that. Pause, rewind, watch it at double speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks. In question 11, they give us this diagram here of a graph, and they show us the graph itself. And they simply ask us, find the set of values for which fx, this equation, this graph, is decreasing. So to do that, we can do that visually first of all by just getting a tangent. So if this is going up, if it's going up, a tangent, that the slope of a tangent is going up, it's positive, it's greater than zero. It's going down, it's negative. So when is it decreasing? Well, when the slope is negative. So if we go along, find somewhere around here in my drawing, and it's negative. It stays negative, it's negative all the way down here. Probably goes all the way to infinity, it stays negative. At zero, it's not equal to zero, so we don't have to worry about the actual zero because the world goes a bit crazy at that point. And then we're still negative, we're negative, and at some point around here stops being negative, so it stops decreasing. That's what they want us to do. So when we see decreasing, what they want us to think is derivative. They want us to think the derivative is less than zero. And actually you'll get marks just for writing exactly this. So then they also want you to do the derivative. And before I do that, I'll rewrite fx. Because I don't like writing this way. I like it 4 times x to the minus 3. Much easier, at least in my head. Minus 3 times x to the minus 1. I'm just putting them all in the top row. Plus 2. This I can differentiate so much easier in my head. The derivative of this is minus 3 times 4, minus 12, x, take 1 away from this and we get minus 4. Again, minus 1 times minus 3 is plus 3. Take 1 away from that, we get minus 2. And the derivative of a constant is 0. And if you want, you can rewrite that as minus 12 over x to 4. Because I rather looking at this way, but I rather working with it this way. So that's, forgive me that, maybe you're the same, maybe you're not. This is the derivative. Let's just put it less than 0. And that's what they want us to solve. They want us to solve this equation here. I'll do that under here. We need to be careful. We have an inequality here. So remember, be very careful when you multiply by minuses. So let's keep an eye out for multiplying by a minus. Let's get rid of this bottom row first. Let's multiply x squared. This has 2x squares. This is like x squared times x squared. Let's multiply x squared across. This will disappear, this will disappear. They're both positive, thankfully, because anything squared is positive. Multiply by 0 becomes 0, it just disappears. Multiply by x squared again, I think. Multiply this by x squared, it disappears. Multiply this by x squared, we'll have to put it in there. Multiply this by x squared, 0 times anything. Done. So we get, let's write it over here, minus 12 plus 3, that's a weird 3, 3x squared is less than 0. Let's rearrange, we're allowed to add to both sides, it doesn't matter, or take away even. So we get 3x squared is less than 12. Divide both sides by 3, that's a positive number. X squared is less than 4. At this point, lots of students are just really good at doing this. They know the answer to this is, well, x is less than 2 and x is greater than minus 2. The way I like to think of it is, I like to put this as x squared equal 4. You can also draw a picture, helps. I'll just do it this way. I always do the picture, let me do it this way. The answer to this is x is plus or minus 2. So I like to think of it this way. Imagine if it was a plus 2 here, and we divide both sides by one of those 2's. We'd be left with x is less than 2, because dividing by a positive doesn't change anything. But imagine if it was minus. Divide both sides by that number. I guess it doesn't have to be minus 2, it has to be less than it. Divide both sides by that minus number. The x divided by the x would get the x. The 4 divided by that minus number, minus 2 in this case, would get minus 2, but we'd end up changing the sign because we did it. That probably didn't help. It's probably just better drawing a picture of this idea. Let's see, x squared looks like this, and being less than 4. Being less than 4. When's x squared less than 4? Well, it's when it's bigger than minus 2 and less than plus 2. Anyway, however you get to it, this is the answer. You will lose a mark if you just put this together, like x is bigger than minus 2 and less than 2. You will lose a mark for just this as your answer. I guess just for this as well, they want you to acknowledge what they gave you. X not equals 0, so this is wrong. They want maybe, probably the best way to write this would be x is between minus 2 and 0, or it's between 0 and 2. It's because it's never 0. Because this implies it's sometimes 0. Also, if I wrote this, that to me, that's the same as that. This would imply it's sometimes 0. It's bigger than, it's less than 2 and it's bigger than minus 2. Well, it's sometimes 0. It's not. So you need to tell them that. You could just add in here x not equals 0. That's fine. That's full marks. Okay, let me clean this off and we'll go on to part B. If you watch multiple of my videos, hopefully you've heard me say draw it when you can. And in part B, that's very important because it's hard to understand what they mean. They say a triangle is bounded by the y-axis, the norm bounded just as this is the size of it. The y-axis, the normal, and the tangent make this triangle. And they tell you a bit about that. Let's try and draw it first. So the y-axis, that's there. The normal to the curve at the point where x equals 1. Well, we now know it starts going up around 2. 2's there. So let's say 1 is, it doesn't really matter. 2, I don't have to be too accurate. Just a little idea is what I want. Let's say 1 is here. Here's 1. So the normal at this. So what's the normal? It's the opposite to a tangent. That's a tangent. A normal just is perpendicular to a tangent. It looks something like that. The other one is the tangent to the curve at minus 1. So let's say minus 1's around here, and the tangent, let's say, I'm just cheating here because I know it should be a right angle, is like this. And so what does it describe there? The triangle that's bound by all of those. The y-axis, the normal, and the tangent. It'll be this little triangle in here. I'll draw it a bit bigger now because we don't need it to be that small. It's probably not even, doesn't look right. I'm sure your drawing might look very different. The point is, that's where we got all these lines from. There's 8 marks for all this, so it's a pretty big question. As you might have heard me say as well, don't worry about answering their question if you don't know the path. Just answer everything you can. So what I'd be thinking here is, I want to know what this point is, I want to know what this point is, and then eventually I want to find this point, this point, this point, or maybe some of the lengths of this triangle. Because sorry, the question they're asking us is the area of this triangle in here. So let's start on that. We know, I've rubbed out the equation here. Sorry, let me put it back in. Okay, I put the equation back in and the derivative we found in the previous part, because we're going to use that. I want to know this point here. This point is when it was 1. So let's find f1, because we know the x part at this point, just need the y part, which is the f. F1 is 4 divided by 1 minus 3 divided by 1 plus 2, which, what does that equal? 3. So this point here is a 1, 3. I would like then to know this point over here. This is f minus 1. And that equals, let's see, minus 1 cubed is minus 1, so that's minus 4. Then minus 3 divided by minus 1, that's 2 minuses, so we get a plus 3 and plus 2, that's equal to 1. So my drawing is definitely way off here, but it's minus 1, 1 is this point. What else can I find? Let's find the equation of these lines. That'll be helpful. Let's call this line line 1 and line 2. Line 1, this, we have a point on it. We just need the slope, and the slope is just the derivative. The derivative at this point. So the derivative at -1, and we can put that in as well. That's a +1 equals -12. That's a +1 plus 3 equals -9. So slopes down a lot. That's the derivative there. So we can find the equation of this L1, and that's y is equal -9x plus some c. We solve for that by putting this point in, -1, 1. So we'd say 1 is equal -9 times -1 is 9 plus c. C must equal -8. And that's good because that gives us this point. We now know this point here. That's 0, -8, the y-intercept of that line. We also could use that, well, we will in a moment. Once we get the other line, we'll use that to find the intercept. So let's stay going. Let's find L2. L2 is y is equal m. In this case, oh sorry, I never found m first. I want the derivative at 1. So let's do that all in our heads. Put a 1 in here, we'll get -12 plus 3. We'll get the same slope actually. The slope at this point is the same as the slope at that point. That was the cheat I mentioned earlier. I knew I'd get the same slope. So this is also, sorry, I was about to say this is also -9 the slope, but of course this is not a tangent, it's a normal. So it's not, the slope isn't -9, it's the opposite. It's upside down, change the sign. So it's 1/9 times x plus some c. Let's find out what that c is. Fill in the numbers. We get 3 is equal to 1/9 plus c. C must equal, let's see, this is 27/9. Must equal 26/9. So again, that gives us the y-intercept here. So this guy up here is 0 and 26/9. The last point I'd love to know is this point here. This point out here, and that's just the intersection of these two lines. So let's write them out in their entirety. This guy's y is equal -9x -8, and this guy over here is y is equal 1/9x plus, is that right? Yeah, plus 26/9. Just equate these together. It's not a pleasant one to do. If we take these away, we'll end up with, what's this? This is 81/9 minus 81/9 minus another 1/9. So this will end up as, I guess, this time minus this 0 is equal 81 minus 1 is 80/9. X. And minus 8, I guess, is minus 72/9. Minus 72, take away another 26 is 98. So that's minus 98. Solve for this, we'll get x is, actually before we solve for that, let's put that 9 back in. Solve for this, we'll end up with x is equal to, let's see, 98 divided by 80. I'm sure we can break that down a little bit, but I'll just leave that for the moment. And we could go get y, put it back into either of these, where have we got the two equations? Either of these two guys, you could solve for y and find the 3 points. And at that point, there's a few ways to get a triangle, area of a triangle. One of them is if you knew all 3 points. Yeah. But there's actually a clever way with only the x. This point here is, let's see, it's 98/80 and something. Here, I thought it was a neat little trick. We don't need to know the something, because look what x tells you. It tells you the length of this, because remember, we're on the y-axis. So this length here is actually 98/80. I guess I should look up, sorry, it's minus, first of all, minus 98, and it breaks down to, just minus 49/41. So actually that should be 82 in that case. 82, I must have done that wrong in my head. Serves me right for trying to do it in my head. So 82. This length though still is positive. Obviously lengths are positive. this length's positive. We can get the length between these two. It's just here's the 0 point here. So it's just the top part 26/9 plus the bottom part 8, and so this total length here is the total length is 98/9. So the area of this triangle is a half times the base 98/9 multiplied by the height, which is 98/82, which I really hope there's not a mistake in that, but I'm guessing there probably is, which comes out to 2,401 divided by 369. No, I just checked the calculator, that works out. That is the correct answer. They asked for 3 significant figures though, so give them decimals. That's 6.51. And that's it for question 11, which that's it for the whole exam. Thank you for watching. If you have any questions, I think I rushed through some of that. It's a messy question. These late questions are hard, but if you have any questions, if you need any extra help, let me know in the comments. I'll do my best to answer. Thanks for watching. Have a great day.